So in this lecture we're going to look at how resultant forces can affect someone that is falling and look at something called terminal velocity. So we've got here a skydiver and we're going to imagine that they've just jumped out of a plane, and they jumped out of a plane about half a second before this snapshot was taken, and they're currently travelling at a velocity of 5 meters per second. So we're going to add a few forces onto here. Obviously the one force that always applies is the skydiver's weight. They're being pulled down towards the surface of the Earth, so we're going to add the skydiver's weight, and we're going to represent that with this downwards arrow. Now, as they are falling, they're not travelling very fast at the moment, just half a metre every second. Air is going to be hitting them as they are falling towards the Earth, so there will be a force of air resistance acting upwards on the skydiver. But as you can see quite clearly from the arrows, these forces are not balanced. If we look, there would be a resultant force acting downwards on the skydiver, and that means that the skydiver is going to be accelerating downwards. So their velocity is now going to be increasing quite rapidly. If we go to a little bit further on in the timeline and we look at a skydiver, the same one, 3 seconds have passed now and they're still falling, but now their velocity is much greater. So remember, their weight is going to remain unchanged from before. Unless they lose a limb or something like that, their weight is going to remain constant. But because they are now falling at a faster rate, more air is going to be hitting them every second, so the air resistance would have increased in size. So they still don't quite balance up. We still have a resultant force acting in the downwards direction, so we're still going to be accelerating downwards, but we're going to be accelerating at a much slower rate. So the velocity will still be increasing every second, but the rate of acceleration will have slowed. Eventually, we will get to the point, and we're going to look at 12 seconds after the skydiver has jumped out of the plane, where the weight still remains unchanged, but now they're going so fast, about 55 meters per second, there's so much air hitting them, the air resistance is increased to the point now where it completely balances out the weight. Now that doesn't mean they're going to stop moving. Remember, Newton's first law says if there are forces acting on an object and they're balanced and it's already moving, it will stay at a constant velocity. So in this circumstance, there is no resultant force, so there's going to be no acceleration. It's going to be a constant velocity. Now this constant velocity that's achieved through the balance of air resistance and gravity is often referred to as terminal velocity, because unless the situation changes, this is the final velocity that you will reach. Obviously, we know from experience that the skydiver will release a parachute, which would greatly increase the air resistance, so they would then start to decelerate. But if everything remains unchanged in this situation, they will keep going at this velocity, and that is what we call terminal velocity when air resistance is balanced with weight.